So here are my visual aids and my note cards. You wake up one morning with chills and a fever. You're developing a cough and shortness of breath. Make an appointment with your doctor. He tells you that you have pneumonia. He prescribes you penicillin. So you know it is an antibiotic, you really don't know a whole lot about it. Today I'm going to inform you about antibiotics, what they are and how they're different from disinfectants, how they are discovered, how they work, and even how to test them in a laboratory setting. So first I'll describe what they are and how they differ from disinfectants. Defined by Slawomski and Foster in the Microbiology and Evolving Science textbook, antibiotics are molecules that compel or inhibit the growth of selected microorganisms. Antibiotics are used on humans and are safe for human consumption. Differently, according to Seymour Bloch's 2001 book, Disinfection, Sterilization, and Preservation, disinfectants are agents that free people from infection. Disinfectants are typically used on its surface opposed to on its surface. Disinfectants can be chemical or physical. Chemical, common one is bleach, which is actually in liquid form applied to a bacteria. Physical, on the other hand, can be UV light or X-ray to kill bacteria on the surface. Now that I've told you a little bit about what they are, I'll tell you how they were first discovered. Alexander Fleming is the most famous discoverer of penicillin. According to the history of antibiotics from experimentalresources.com, in 1928, Alexander first discovered penicillin when looking at the influenza virus. He noticed that when he placed the mold Penicillium notatum on a lawn of bacteria, that it exhibited a bacteria freezer. It inhibited the growth of bacteria. He was able to collect this juice that he called it from around the mold and named it penicillin. For this work, he earned the Nobel Prize in Physiology and Medicine in 1995. Though he was the most famous to discover antibiotics, he was not the first. Ancient Chinese medicine and Greek medicine also used antibiotics using plants and molds to treat infections, but not really knowing why. Also, experimenters like John Parkinson, Joseph Lister, and John Tyndall also played with the idea that molds could treat infections, but didn't really go into it too much. So Alexander Fleming was the most famous to discover antibiotics. He was not the first to discover penicillin. From Do You Know This, who discovered penicillin from the Sleep and Health Journal, Ernest Duchesne, a French medical student, was actually the first to discover penicillin. He discovered that the Penicillium glaucum mold, when injected into typhoid-infected guinea pigs, actually helped them recover. So he was too young to be given credit and not a well-known scientist. So therefore, 30 years later, when Alexander Fleming rediscovered penicillin, he was given credit. Now that I've given you some history, I want to let you know how antibiotics work. According to the article, How Do Antibiotics Work? From Discovery, Fit, and Health, antibiotics have the ability to disrupt a bacteria's ability to turn glucose into energy and also disrupt its ability to construct its wall. These both prevent the bacteria from reproducing and therefore kill the bacteria. Antibiotics also only act on the bacteria. They are not able to act on human cells, so it makes antibiotics safe for humans. Now I told you a little bit about how antibiotics work. I'll let you know how we can test antibiotics on bacteria and their susceptibility. From the textbook Microbiology, an introduction written by Portuo, Funk, and Chase, 2010, explains this diffusion method. This diffusion method, also known as Kirby-Bauer, is another way to test antibiotics. You lay a lawn of bacteria on a plate and then apply small discs soaked in antibiotics of different concentrations to this plate and look at the differences of inhibition. As you can see from this paper, this visual aid, that you can see that this is the inhibition zone. We call it the zone of inhibition. These discs are all antimicrobial discs soaked in different concentrations. By measuring the zone of inhibition, we can actually tell how susceptible a bacteria is to an antibiotic. You can see on this one, on disc E, that it has a much larger zone of inhibition than disc B. This means at this concentration of this antibiotic, it is much more effective than this concentration of this antibiotic on killing the bacteria. Now that I've told you a little bit about how to test them, I hope that you have learned about antibiotics and disinfectants and the differences, how to distinguish the terms, and also the history and how they work, and even how to test them in a laboratory setting. I hope you can take something away from the information I've provided today. You know how we deal with bacteria and disease, and now you know at least more than when the doctor tells you you're sick and that just gives you antibiotics. You now have the knowledge of how antibiotics work and know a little bit more about them.